Hello students, welcome back. In our last lecture, we have completed Unit 2 Polynomials. In this video, we will start with Unit 3, which is Coordinate Geometry. So first of all, let's talk about some basics of Coordinate Geometry. What is Coordinate Geometry? What are the points which we should know before doing this unit? So, Coordinate Geometry, there is a coordinate plane. A coordinate plane is where a horizontal line, this is a vertical line and this is a horizontal line, this one, and we call them as x-axis. This horizontal line is known as x-axis and this vertical line, it is called as y-axis. And the point where they meet, this point is called origin, O, and it is represented by O, origin, O. And this entire plane in which this entire thing is there is known as Cartesian plane. Cartesian plane or coordinate plane or coordinate plane. Okay. Now, if you see, this part is divided into 4 parts. This one, this one, this one and this one. They are known as quadrants. This one is known as first quadrant, this is second quadrant, this is third quadrant and this is fourth quadrant. And we can find place of any digit. If there is a point, like here there is a point, we can find the place of that point. Exact coordinates, they are known as coordinates. They are known as coordinates. So, if I join this point to y-axis and a vertical line to x-axis, the point at which they intersect x-axis and y-axis, this point, this one and this one, they are coordinates of this point. And how are coordinates written? They are written as x, y, where x is the value of point on x-axis. Let's suppose it is 5 and this is 4. So the coordinates will be 5 and 4. The coordinates of this point will be 5, 4. Always keep in mind that point on x-axis is written first, then on y-axis. If the point is here, this is known as, we can write it as x dash and this is as y dash. And the coordinates of origin are 0, 0. And the x coordinate 5 is called abscissa. And the y coordinate 4, it is called ordinate. Okay. In this 5 and 4, 5 is abscissa and 4 is ordinate. In this, signs of x, abscissa and ordinate are positive and positive. X is also positive and y is also positive. In this quadrant, x is negative, abscissa is negative and ordinate is positive. In third quadrant, both are negative, minus and minus. Abscissa is also negative and ordinate is also negative. And in fourth quadrant, abscissa is positive, x-axis is positive and y-axis is negative. Ordinate is negative. So these are some basic terms you should know before starting this unit. And if there is a point like on x-axis, if this is the point, then what will be the coordinates? Let's suppose this point is 2 here, on you would need a graph for this. So if you see on a graph, the points are 1, this is 2, this is 3, this is 4, this is 6. If you want to know the coordinates of this point, it is lying on x-axis. So the coordinates will be 2, 0. 2, 0 will be coordinates of this point. And in the same way, if the point is lying here on y-axis, this, and let's suppose this point is -3. So the coordinates of this point, they will be 0 and -3. Okay. So in this way we have to solve the questions. So this was the introduction. Now let's start with exercise 3.1. Let me just rub it off. Exercise 3.1. In exercise 3.1, first question is just about introduction or a activity. So let's start with second question. Second question says that a street plan. A city has two main roads which cross each other at the center of the city. The two roads are along the northwest direction and east-west direction. So first of all, let's draw question number 2. There are two roads in a street, in a city, and they are saying that they cross each other. One is in the northwest. We all know this is north, this is south, this is east, and this is west. They are saying one road is going in the north-south direction and one is in the east-west direction. And they are crossing each other. Okay. Now they are saying all the other streets of the city run parallel to these roads. All the other streets run parallel to these roads and are 200 meter apart. Like if there is a street running parallel to this north-south, then the distance between them is 200 meter. Okay. There are about 5 streets in each direction. They are saying that there are about 5 streets in each direction. That means 1, 2, 3, 4 and 5. 5 streets parallel to this north-south. In the same way, 1, 2, 3, 4 and 5. 5 streets parallel to the east-west direction. Okay. So now this is the figure. You have to solve it on graph. You should use a graph. Okay. There are about 5 streets in each direction. Using 1 centimeter is equal to 200. They are saying that if you are making it on a paper, then we should consider 1 centimeter as 200 meters. So this means if this is 1 centimeter, so on graph 1 centimeter is equal to 200 meters. Okay. In real, we have to use 1 centimeter, but on paper, because we can't show a gap of 200 meters on a paper. So we should use 1 centimeter. This is 1 centimeter. Okay. Now the question says, draw a model of the city in your notebook. We have drawn it. Represent the road streets by single lines. We have shown this. There are many cross streets in your model. Yes. Cross streets. Which are the cross streets? Like this point. One is going in north-south and one is running in east-west. So this is a cross street. This is also all the points. All these points are cross streets. Okay. One running in the north-south direction and another in the east-west direction. Each cross street is referred to in the following manner. If the second street running to north, which is the second street? First, second. This one. second street running to the north and north-south direction, and fifth in the east-west direction. Fifth in east-west. First, second, third, fourth and fifth. This one. East-west direction meet at some crossing. So, second in the north-south and fifth in the east-west. They are crossing at some point. Which is that point? This point. This is the point. Then, we call this cross street as 2-5. We are calling is at 2-5. So, they are saying that second street in the north-south and fifth street in the east-west. When they cross at a point, that point is known as 2-5. So now they are asking, using this convention, find how many cross streets can be referred to as 4 and 3. First part. First part is 4 and 3. 4 and 3 means 4th street in the northwest, north-south. So north-south, 4th street, first, second, third, fourth. This one. And 4, 3. 3, second one means 3rd street in the east-west direction. So first, second and third. This one. So they are intersecting at this point. So this is 4, 3. So they are asking how many cross streets can be referred. So how many cross streets? As you can see, there is only one cross street here. This one point. So answer is 1. Now the second part. Second part says, how many cross streets can be referred to as 3, 4? 3, 4. 3, 4 means, 3 means 3rd street in the north-south direction. This one. First, second and third. This one. Okay. And 4th street in the east-west direction. So first, second, third and fourth. This one. So third, this one and fourth, they are crossing at this point, which is 3 and 4. So now they are asking how many streets can be referred as 3, 4. So again, only one street. There is only one cross street here at 3, 4. So answer is 1. So this was exercise 3.1. There was only one question, 2 questions. First question was an activity. Second was this question. We have solved it. For exercise 3.2, we will start in the next video. So thank you very much.